Hello, my name is Maverick Collins. This is Ron McKellen and James Owen, and we are on Team RuneScape in Professor Hughes's class, Software Engineering 2, here at Grand Canyon University. And this is our Milestone 3, where we're going over the integration of our ESP32s with our Raspberry Pis using MQTT Telemetry. And Ron's kind of go over some of our technical details and share what we built.
All right, so the core of the project is that we have refactored the MQTT sample in order to break the Wi-Fi MQTT components into their own thing. And we added the DHT11 component previously developed in class to this project to enable sensor reading. The main C file is relatively short. It only contains the headers and functionality necessary in order to initialize other components, the Wi-Fi and MQTT, at which point it just reads from the sensor and publishes payloads without worrying about the internals. Meanwhile, each component, such as the Wi-Fi, for example, has its own implementation details broken off with its own logging facilities and an external API defined in a header file. The API is intentionally kept simple, so that way the main program only has to worry about initializing and waiting for connectivity, where the MQTT only worries about initializing and publishing. And of course, the DHT11 reads from the sensors just as we'd always done before. Now, moving to the actual wiring, the wiring is the same as done in class, with the data line from the sensor being connected to the D4 pin on the ESP32, and the power lines for both 3.3 volts and 5 volts being connected appropriately to each device. The actual topic reading works properly and was tested using Mosquito Sub on the Raspberry Pi, which shows the output from the telemetry, temperature, and humidity as necessary. While the build was successful and the monitor was operational on the ESP32 and in VS Code. So overall, the actual architecture of it has been broken up so that way there are three components: MQTT, Wi-Fi, and the DHT11 reader, while the main C file is slimmed down significantly so that way it only depends on those components and not specific details of, say, the MQTT client supplied by Espressif itself. And that will be off to you, James.
Wait, hold on. Okay. So the topics that the MQTT that the ESP32 reads and publishes are temperature, humidity, and telemetry. The the info that the topics are read from each one being temperature. This is the output from the Raspberry Pi, temperature C and temperature F. Temperature in Celsius and temperature in Fahrenheit. And humidity, it's always going to be the percentage of humidity in the air. And for telemetry, it's going to be the device, the amount of times it is pinged, the other is pinged, and the since last error. The last, and when you use the mosquito protocol, this is what you should, and use this particular command, this is what you'll be getting every ping. Telemetry, temperature, and humidity. And that's pretty much it for the MQTT. Uh, Moving back to you, Maverick.
All right, thank you guys. So in conclusion, this was a very foundational milestone for our learning in embedded systems and software engineering overall, where we got to encapsulate our Raspberry Pi embedded systems with another system using the ESP32 and learning the communication protocol MQTT to transmit messages in a rudimentary fashion between the two devices. We'd like to thank Professor Hughes and everyone else that helped us along the way, and we'll see you guys on the next one. Thanks.